With this lesson, we're going to start the last unit of the school year in geometry, and it's probability. So it will be a big change of pace from learning about shapes. This lesson is about finding the probability of a single event. Learning goals are to understand probability, represent sample spaces by listing items, and to calculate the probability of an event. First thing we should probably do is define what we mean by probability of an event. Probability is a number used to express the chance that something is going to happen. Take a look at number 1. Suppose that you have a cube with faces numbered 1 through 6. We call this a die when you're playing board games. And you roll the cube 60 times. On roughly how many rolls would you expect to get an even number? 3 out of the 6 faces on the cube are even numbers. So half of the things that could happen are even numbers. If we roll about 60 times, we would expect about half of those times to end up as even numbers, or 30 times. On roughly how many rolls would you expect to get a 5? Well, this time only one face out of the 6 faces is a 5. If we roll 60 times, we're expecting only about 1 out of 6 of the 60 rolls to end up having a 5 on the top of the cube. That's 10 times. Question C. On roughly how many rolls would you expect to get a number that is 5 or more? Well, on a 6-sided cube, to get 5 or more, you have to roll a 5 or a 6. So 2 out of the 6 things that could happen are a 5 or a 6. If we roll 60 times, we would expect 2/6 of the 60 rolls to be 5 or more. And that turns out to be 20 times. These fractions that I was considering in order to find my answer are probabilities. There's a short notation to write down probability. It's to use a capital P and then in parentheses to briefly describe the event that you want to occur. For example, the probability of rolling an even number could be written as P and the word even in parentheses. That doesn't mean a lot without knowing that the original context is about rolling a die. Question 2a, when you roll the cube, what is the probability that you get a 5? And use probability notation. So a capital P, and then in parentheses, we want to describe our event we're interested in. Simply putting a 5 is enough if we know the original context. How many faces on a die are a 5? That's only one of them. Now in the denominator, how many faces are there total? There are 6. So the probability of getting a 5 is 1 out of 6, or 1/6. When you roll the cube, what is the probability you get 5 or more? So this time we might say P parenthesis, and we could write 5 or more, or we could write 5 or 6. What's the chance you get a 5 or a 6? Well, 2 of the faces match that situation, and there were 6 possible faces on the cube. There's a 2 out of 6 chance of rolling 5 or more. On the next page, there's some vocabulary. Rolling the cube is an example of a probability experiment. There are other probability experiments that don't involve rolling a die. When you play card games, drawing a card is a probability experiment. If you spin a spinner in a game, that's a probability experiment. If you flip a coin and are interested in what's the chance of getting heads or tails, that is a probability experiment. The result of any probability experiment is called an outcome. When you flip a coin, the possible outcomes are a head or a tail. If you roll a die, the possible outcomes are a 1, a 2, 3, 4, 5, or 6. The list of possible outcomes is called the sample space. So to write down the sample space for rolling a die, you would simply list out the numbers 1 through 6. To write out the sample space of flipping a coin, you would write down H and T to represent getting a head or getting a tail. When you're interested in finding the chance that a particular outcome occurs, you call that outcome you're interested in an event. For example, we might say, what is the probability of rolling a die and rolling a 1? And so our event is getting a 1. And we could then figure out that probability. It's 1 out of 6. Here at the bottom of the screen is the mathematical definition of probability. To find the probability of any event, you make a fraction. The top of the fraction is the number of outcomes in the event, and the denominator of the fraction is the total number of outcomes possible. Let's use that definition to do number 3. A regular solid has 4 faces. The faces are numbered 1 through 4, so 4 outcomes are equally likely. We're going to roll it once. What's the sample space for the experiment? We could roll a 1, a 2, a 3, or a 4. Now question B, let's find some probabilities. What is the probability of getting a 2? Well, what goes in the numerator? How many 2s are possible on that solid? There's only 1 2 on there. What goes in the denominator? It's a 4 because there's 4 possible things in the sample space. Question 2, what's the chance of getting a number at least 2? So we want the probability of getting a 2, a 3, or a 4. All of those numbers are at least 2. I'll pause the video for you to try this one. And the answer is 3 out of 4. Now question 3, what's the chance of getting a number greater than 4? So we want to somehow write that. We want to get greater than 4. I'm using the greater than just to save writing. I'll pause the video for you to try that. And the answer is 0 out of 4, or simply 0. There's no chance of getting greater than a 4 on this solid. Next one, a number greater than 0. So we might write that like this. What's the chance of getting greater than 0? I'll pause the video for you to try it. This time the answer is 4 out of 4, or simply 1. There's a 100% chance that that happens. On the next page, it sort of summarizes those results. If an event can never happen, the probability is 0. If an event is guaranteed to happen, the probability is 1, which as a percent means 100%. More often, the probability is something between 0 and 1, some kind of fraction in between 0 and 1. Skip to the check your understanding and go to problem 6. What is the smallest possible value for a probability? I'll give you a second to answer that. The answer is 0. Now do number 7. What's the largest possible value? This time the answer is 1. Question 8. If a student is chosen at random from class today, what is the probability the student is male? Now go to the next page. The contestants for the Superstar contest are as followed, with their genders and ages in parentheses. Notice there are 12 names here. In problem 9, it asks, what is the sample space for the probability experiment? The sample space is this list of 12 people. Now question B, what's the probability that a selected contestant is named Casey James? Well, how many Casey James are in the list? There's only one person. How many people total are there? 12. There's a 1 in 12 chance that the person is Casey. Now, what's the chance the person is female? We know we're going to have a fraction. Go in that list and count up the number of females. There are 6 girls, and the denominator is 12. So there's a 6 in 12 chance the contestant is female. Whenever you can reduce, you should. Next one, what's the chance the contestant has a last name beginning with Z? This time the answer is 0 out of 12. Nobody has a last name that starts with Z. You should simply say 0. I'm going to pause the video for you to work the next couple of these. And here are the answers. All of the contestants are under 30, so the answer is 12 out of 12, which equals 1. 3 people have a last name that starts with B. 3 out of 12 reduces to 1/4. The number of people that don't have a last name beginning with B are all the rest of them. So if 3 out of 12 do have a name with B, the other 9 of them do not. 9 out of 12 reduces to 3/4. On the next page, that last situation is described a little bit, and the vocabulary word is used for it. That word is complement. The complement of event is everything else that's not a particular event. For example, the complement of people whose last name starts with B is all the people whose last name doesn't start with B. Next, go to number 10. Jenna and James are recently married. They're planning to have 3 kids. They're wondering how many girls and how many boys that they will have, and assume that there's an equally likely chance to have a girl or a boy. Show the possible outcomes for their children using a list. Making a list of outcomes and using letters of the alphabet to abbreviate things is a common skill when working with probability. So in the list, GGG means all 3 of their kids are girls. GGB means the first 2 kids were girls and the 3rd child was a boy. This question asks us to list the other 5 outcomes. So I'm going to pause the video for you to do that. And here are the other 5 results, although yours might be in a different order. The order doesn't matter. You just want to be logical about it so you don't skip any by accident. Now that we know the sample space, we can answer probability questions. Remember that the number of items in the sample space is the denominator of your probability fraction. So what is the probability that the family has 3 girls? Well, there's only one situation that goes GGG, and there are 8 total, so there's a 1 in 8 chance of that. What's the chance there are exactly 2 girls? This time we want to find all the events where there are 2 G's listed. That's here, 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 and that's it. So there are 3 out of 8 where there's exactly 2 girls. Now the next one is at least 2 girls. This means there could be 2 or 3 girls. So this time it's 4 out of 8, or a half. Jump ahead to the check your understanding question where number 11 is. Iris rolled a 5-sided number cube. So unlike most dice that have 1 through 6, this only has 5 sides. Find the probability that the roll will result in each of the following and write the answer using probability notation. So question A, what's the chance of getting an odd? Well, on the 5-sided die, that would be getting a 1, a 3, or a 5. So 3 out of the 5 possible things are odd numbers. I'm going to pause the video for you to answer B, C, and D. So question B, the chance of not getting an odd is 2 out of 5. It's the rest of them. If 3 out of 5 are odd, the other 2 of them are not odd numbers. Question C, the chance of getting a 4 is 1 out of 5. Only one face of the cube has a 4 on it. The chance of not getting a 4 is the rest of them, the other 4 of them. So 4 out of 5 is the answer. Let's summarize this lesson. We have started into our final unit about probability, which we'll work on for the remaining weeks of the school year. Probability simply means what is the chance that an event can happen, and we use a number, usually a fraction, to represent that chance.